Now we'll look at how to deal with roots when we don't have square roots necessarily. I want to show you a trick that will help us in this section and in the next section. So first of all, let's look at in this example just to see what this is really saying. This is called the cube root because there's a 3 there. The cube root of 1. And that means we're really looking for something times itself 3 times or something cubed which is equal to 1. And this, of course, is 1, because 1 times 1 times 1, or 1 cubed, is still 1. So now let's look how to find something if we don't know it. We're going to look at 1296. And we're going to break this down into prime factors like we've done in other sections. So first of all, we want a prime number that goes into 1296. And let's use 2 because it's even. So I'll take 1296 and divide by 2, and that gives me 648. 648 can still be divided by 2, so I'll put the 2 out here, and that's 324. I can still divide that by 2, and that's 162. I can still divide this by 2, and that's 81. Now 81 isn't even, so I can't divide it by 2, but let's try 3. That gives me 27. Let's try 3 again. It will give me 9. And one more time, 3, which would give me 3. Now once this number on top is prime, I know I'm finished. And I want to use all of these numbers that are on the outside. So what this really gives me is the 4th root of, and I'm going to write all of these outside numbers inside of here. And that's 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. Now what this 4 tells me is I'm looking for numbers that are in groups of 4. So this 2 is there 4 times, and this 3 is there 4 times. Now if it's there 4 times, that means I can pull it out. And when I pull it out, it becomes just a plain 2, single 2. And this 3 would get pulled out, and it becomes a plain 3. There's a multiplication sign between them. And that leaves nothing left inside of this root, this radical. And so we don't have to write the radical any longer. We just take 2 times 3, and we get our answer as 6. Now you can check that. If you do 6 to the 4th power, you should get 1296. So here's another one. This is the 5th root of 243 over 32. And remember, that really means the 5th root of 243 over the 5th root of 32. So let's start with that 243. 2 will not divide evenly, but let's try 3, and that would give us 81. If we do 3 into that again, that gives us 27. If we do 3 into this again, it gives us 9. 3 goes into 9 3 times. So on the top, we really have the 5th root of 3 times 3 times 3 times 3 times 3. Now let's look at the 32. That's even, so we'll divide by 2, and that gives us 16. We can divide 16 by 2, and that gives us 8. Divide 8 by 2, and that gives us 4. Divide 4 by 2, and that gives us 2. So in the bottom we have 2 times 2 times 2 times 2 times 2. Now again, this is here 5 times. We're looking for groups of 5 because this number out here is a 5. That 3 is there 5 times, so it will come out. And when it comes out as a single 3. This 2 is here 5 times. Again, we're looking for 5s because of this number right here. Because it's there 5 times, it will come out as a single 2. So our answer is just 3 over 2. So let's look at this one. This is the cube root of 5 cubed. Now we talked a little bit in the last section about how when we had something squared and a square root, they're opposites of each other and they cancel each other out. This is the same idea. We have a cube root and a cubed. They're opposites of each other, opposite operations, and so they cancel each other out, and we're just left with 5. Now we could do that. Let's do 5 in order. This 5 to the third really means 5 times 5 times 5. And that would give us 125. And then we'd want to take the cube root, which if we go back up to here, this shows us that that 5 is there 3 times. It matches this. So it can come out. When it comes out once, which gives us this answer. So here they're really just wanting you to recognize that when you have a root and an exponent that match, they're canceling each other out. This exponent would tell us that this 5x minus 4 is written there 5 times. And because it's written underneath that radical 5 times, it could come out once because of this 5, the group of 5, would come out once and we would just be left with 5x minus 4. And if it's just by itself, we don't really need the parentheses any longer. So this is just my answer. Fractions in the exponent position tell us information. It tells us the numerator tells us the power, and the denominator tells us the root. So it's a little hard to see it on here, but this is n over d, and that means that we could have the d root of a to the n, or the d root of a all to the n. Either way. So this wants us to write it as a radical. This is b to the 1/6. So the top tells us it's b to the first, and the 6 on the bottom tells us it's a 6th root. Now we don't need to write that first power right there. So this is my answer. This wants us to write it with a rational or a fraction exponent. So let's put the 2y in parentheses. There's no exponent inside there, so it's understood to be a 1. So that's going to be our top, and the root is a 5th root, so that will be the bottom of the fraction. So we have 2y to the 1/5 power. Okay, this is the same idea. This 2, though, is kind of in front. Let's put a dot between them so that we can just keep them separate for our eyes. Remember that if there's no exponent here, there's really a 1. So the 2 would stay out here, and then we'd have our parentheses, 8y. The 1 would be on top, and the 6th power would be a 6 on the bottom. So it'd be 8y to the 1/6 power with the 2 just staying out in front.